Before we begin, find yourself somewhere comfortable. Let your shoulders soften, let the day settle behind you. This is a story told at the pace of starlight, meant for quiet hours when the mind is ready to wander gently outward. There is no rush here. The sky has been patient for billions of years. It can wait for us to listen slowly. Somewhere beyond the familiar orbits of the planets, beyond the gentle arc of Saturn's rings and the distant shimmer of Neptune, a traveller has been moving through the dark, not racing in any dramatic sense, not blazing with intention as in the movies, but simply following a long ancient curve carved by gravity long before our species learned to look up and name the constellations. When astronomers first noticed this object, they recognized something unusual about its path. It was not looping around the sun in the calm ellipse of a typical comet born here at home. Instead, its trajectory was open, stretched into a long hyperbolic arc, an orbit that does not close, an orbit that does not promise return. For months, we watched it slip inward through the solar system, growing brighter as it approached the sun, passing at a respectful distance from Earth, never threatening, never dramatic, just a visitor, the kind that arrives without ceremony and leaves without farewell. And yet, in the quiet corners of conversation, a question began to form. What if it does not leave? The mathematics of celestial motion are steady companions. They describe how gravity bends space into curves and how objects follow those curves faithfully. According to those equations, this visitor has more than enough speed to escape the sun's pull. It should pass through, receive a subtle nudge from the giant planets, and continue outward, fading slowly into the interstellar dark from which it came. That is the expected story. A one-way journey, a brief crossing of paths. But there is a moment ahead, a meeting not with Earth, but with something far larger and far more patient. Jupiter waits. Jupiter, with its mass more than 300 times that of our planet, is less a world and more a gravitational presence. It does not simply orbit the sun, it shapes the architecture of the entire outer solar system. Comets bend around it. Asteroids scatter before it. Even the faint debris of distant space must acknowledge its influence. Every planet has a boundary where its gravity begins to dominate over the sun's pull, a quiet region astronomers call a Hill sphere. For Jupiter, this region stretches tens of millions of kilometers into space, forming an invisible shoreline in the ocean of gravity. Cross that shoreline, and the rules subtly change. In a few months' time, this interstellar visitor will skim that very boundary, not plunge into Jupiter's clouds, not spiral dramatically into orbit, simply pass near the outer edge of its gravitational domain, where the Sun and Jupiter engage in a slow, silent negotiation over who holds greater sway. It is here, at this edge, that the idea of return quietly appears. If an object passes close to a massive planet, its path can be altered. Space agencies use this principle deliberately, sending spacecraft slingshotting around Jupiter to gain speed or change direction. A gravity assist, they call it, though nothing about it feels hurried. It is simply gravity doing what gravity does, transferring energy through motion. Most objects that sweep past Jupiter are nudged only slightly. A subtle curve, a small adjustment. They continue on their way, just as this visitor is expected to do. But when you look at the numbers closely, there is a delicacy to the approach. The predicted distance of closest encounter lies remarkably near the outer limit of Jupiter's gravitational sphere. Not deeply inside, not far outside, but brushing the threshold where influence becomes meaningful. In astronomical terms, such alignments are not impossible. Space is vast and probabilities eventually play out. Still, there is something quietly poetic about an object that has travelled between stars, arriving at precisely the boundary where our solar system's largest guardian exerts its strongest reach. It feels like a fingertip touching the surface of a still lake. Now, it is important to breathe here, and remember that physics is not easily persuaded by poetry. The visitor is moving quickly, far too quickly by conventional calculations to be captured. To remain bound to Jupiter would require shedding an enormous amount of speed, more than natural processes are likely to provide. Under ordinary circumstances, the outcome is simple: a bend, a curve, and onward into the dark. And yet, small uncertainties always exist. Comets are not solid stones gliding smoothly through emptiness. They shed material as they warm. Jets of gas erupt from their surfaces. Tiny forces accumulate over time. Astronomers call this non-gravitational acceleration, a gentle reminder that even in the vacuum of space, subtle pressures shape motion. These forces are usually minor, predictable, explainable. But when calculations are updated, when new observations refine old predictions, the path can shift slightly. 100,000 kilometers here, a fraction of a day there. In everyday life, such differences would be enormous. In cosmic terms, they are whispers. Still, whispers matter when an object approaches the gravitational shoreline of Jupiter. It is not that scientists expect a dramatic reversal. It is not that anyone credible predicts a sudden U-turn toward Earth. Rather, there is an awareness that this encounter is a test, a moment when theory meets reality, when equations drawn on screens meet the quiet choreography of actual planets and actual motion. And so the question lingers, not urgently, not anxiously, but curiously. What if gravity does something slightly unexpected? What if the curve is a little sharper than planned? What if fragments break away and take their own paths? It is perfectly okay if your mind drifts here, imagining that curve in slow motion. A distant object arcing past a striped giant, sunlight glinting faintly off ice and dust, Jupiter's immense gravity reaching outward like an invisible tide. There is nothing threatening in this image, only scale, only patience. For most of human history, we could not even see such visitors. They would have come and gone unnoticed, silent wanderers passing beyond the limits of naked vision. Only recently have our telescopes become sensitive enough to catch these faint travellers against the crowded backdrop of stars. This means our sample size is small, very small. We have seen only a handful of objects that clearly originate from beyond our solar system. With so few examples, it is difficult to say what is typical and what is rare. We are still learning what an interstellar wanderer looks like when it behaves entirely naturally. Perhaps this one is ordinary for its kind. Perhaps its path is exactly what any ancient fragment of ice and rock would trace when passing through a system like ours. Or perhaps it carries subtle surprises that will teach us something new about how gravity shapes encounters between stars. The beauty of this moment is that we do not need to decide. We only need to watch. In the coming weeks and months, telescopes will follow the visitor as it grows fainter, slipping outward through the constellations. Instruments will refine its orbit again and again, and slowly, almost imperceptibly, it will approach Jupiter's domain. There will be no fanfare, no cosmic drum roll, just data arriving quietly, numbers updating, trajectories smoothing into certainty. Whether it bends slightly more than expected or follows its predicted arc with perfect obedience, the encounter will deepen our understanding, and that is enough. So let us leave the visitor there for now, drifting toward the great planet, its path drawn in elegant mathematics and softened by uncertainty. Let us imagine Jupiter waiting, vast and striped, surrounded by its retinue of moons, its gravity extending outward like a calm, invisible sea. In our next quiet step, we will move closer to that sea of gravity itself. We will explore what it truly means to cross a hill sphere, to enter the domain of a planetary giant, and why even a slight brush with Jupiter's influence invites both caution and wonder. For now, simply rest with the image of a wanderer nearing a boundary, an edge where motion may bend, but patience remains absolute. Jupiter does not rush to meet anything, it simply waits. Out there, beyond the warmth where water once flowed freely on Mars, beyond the quiet ringed elegance of Saturn's future path, Jupiter turns in its slow rotation, wrapped in bands of cloud and storm. It has been turning like this for more than 4 billion years, shaping the architecture of our solar system without intention, without drama. Its gravity is not aggressive, it is patient. When we speak of Jupiter's hill sphere, we are describing something invisible yet immense. Imagine the Sun's gravity as a vast ocean filling the solar system, holding every planet in a steady embrace. Within that ocean, Jupiter creates its own tide, a region where its pull becomes stronger than the Sun's for objects nearby. That region forms a boundary, not a wall, not a sudden line, but a gradual shoreline where influence shifts. If you were to drift toward Jupiter slowly, you would not feel a sudden tug. You would simply notice that the curve of your path begins to belong more to Jupiter than to the Sun. This is the hill sphere, a sphere of influence extending tens of millions of kilometers from the planet's center. It is wide enough to cradle dozens of moons, wide enough to shape the orbits of countless small fragments of ice and stone. Our interstellar visitor is not heading deep into that sphere. It will skim the outer edge, brushing the quiet shoreline where gravitational authority changes hands. In everyday language, it is tempting to describe this as a slingshot. The word suggests speed and force, a sudden whipping motion. But the reality is softer. Gravity assists are more like gentle curves carved into motion over time. When a spacecraft passes Jupiter, it does not collide with power. It glides through a shifting geometry of attraction. Energy is exchanged, but no energy is lost or created. It is simply redistributed between moving bodies. This is how we have sent our own machines outward. Probes travelling to the outer planets borrowed a little momentum from Jupiter's immense orbital motion around the Sun. In return, Jupiter's orbit shifted by an amount so small it cannot be measured. The exchange is real, but it is delicate. If a human-made spacecraft approaches at the correct angle and speed, that borrowed momentum can send it racing towards distant worlds. But our visitor is not approaching in a carefully planned trajectory. It arrives with the speed it carried between stars, far greater than most objects born within this system. At its closest approach, it will still be moving tens of kilometers each second relative to Jupiter. That is not a gentle drift. That is a swift crossing, and speed matters. To be captured by a planet, an object must lose enough energy that it can no longer climb back out of the gravitational well. Think of a stone dropped into a deep lake. If it enters slowly, it sinks and remains. If it skims across the surface with enough speed, it may skip once, twice, and escape to open water. Jupiter's escape velocity at the outer reaches of its hill sphere is modest compared to the visitor's approach speed. The mathematics, when laid out calmly, suggest that capture is extraordinarily unlikely. Under ordinary circumstances, gravity alone cannot remove the necessary energy. The visitor will bend, but it will not stay. And yet, even within the certainty of these calculations, there is space for nuance. Comets are not rigid sculptures gliding unchanged. They breathe. As they approach the Sun, heat awakens volatile ices trapped within their surfaces. Gas expands, jets outward, carrying dust and tiny fragments into space. Each jet acts like a small thruster, imparting a gentle push. Most of the time, these pushes are chaotic and balanced, producing only slight adjustments to motion, but over weeks and months, small forces accumulate. Astronomers account for this by including non-gravitational acceleration in their models. It is a quiet acknowledgement that stone and ice are not inert when warmed. They respond, they release, they shift. So when orbit predictions are updated, when new observations refine the visitor's position and velocity, the projected path can move slightly. A fraction of a percent change in speed may translate into thousands of kilometers difference in closest approach. It is not a sign of instability, it is simply the sensitivity of long arcs traced through immense space. Here, at the boundary of Jupiter's influence, that sensitivity feels magnified. A small adjustment in approach speed changes how deeply the visitor dips into the hill sphere. A slight difference in timing alters the geometry of the encounter. The shoreline of gravity is wide but not infinite. Where exactly the visitor crosses it matters. It is comforting to remember that this is not unprecedented territory. Jupiter has shaped countless trajectories before. Long-period comets from the distant Oort cloud have wandered inward and been redirected. Some have been ejected from the solar system entirely, flung outward by Jupiter's influence. Others have had their orbits shortened, transformed into periodic visitors that return every few decades or centuries. Jupiter is sometimes described as a guardian, sometimes as a disruptor. In truth, it is neither. It is simply massive. Its presence redistributes motion. It clears space in some regions and gathers debris in others. It captures small moons under rare conditions and casts away wandering stones without regret. Our visitor will enter this environment briefly, like a leaf carried near a whirlpool but not swallowed by it. If you find your thoughts drifting into images of swirling clouds and immense storms, that is natural. Jupiter's atmosphere is a world of its own. Bands of cream and rust rotating at different speeds, lightning flashing within towering clouds. But the visitor will not touch those clouds. It will remain far beyond them, in the quieter reaches of gravitational mathematics. Still, Something about the scale invites reflection. Jupiter's mass is so great that it subtly shifts the Sun itself. The Sun does not sit perfectly still at the centre of the solar system. It wobbles slightly in response to Jupiter's pull. Even the star bows, just a little. This is the measure of the giant our visitor approaches. And yet, despite that power, the laws governing this encounter are simple and unyielding. Conservation of energy, conservation of momentum, curves traced through space-time. There is reassurance in that simplicity. No hidden forces, no sudden reversals born of whim. When people speak of the possibility of a return, they often imagine something dramatic, a reversal, a turn back toward the inner planets. But gravity rarely behaves so theatrically. It bends paths, yes, but within limits defined by initial conditions. The visitor arrived with more energy than the Sun can comfortably hold. Jupiter's influence may sculpt the arc, but it cannot easily erase that surplus. If anything unexpected occurs, it would most likely be subtle, a change in angle, a slight delay in arrival at some distant boundary, perhaps a small fragment separating, taking a slightly different curve through space. The main body, by all reasonable expectation, will continue outward, and that continuation has its own quiet beauty. To pass so close to a planetary giant and still escape is not defiance. It is testimony to the vast energies involved in interstellar travel. Whatever event sent this object between the stars, an ancient gravitational interaction around another sun, a distant stellar encounter long forgotten, it endowed the traveller with speed enough to cross entire systems without belonging to any of them. There is something almost monastic about that existence. To move through the domains of stars without attachment, to feel their gravity and yet not remain. As we wait for the encounter, telescopes will refine their measurements again and again. Each update will reduce uncertainty. Each observation will narrow the range of possible outcomes. Slowly, the curve will become more certain, like a shoreline emerging through mist. It is okay if you feel both calm and curious at once. Science often lives in that balance. We trust the equations, and yet we remain open to the unexpected. Not because we expect miracles, but because the universe has surprised us before in quiet ways. For now, Jupiter turns, the visitor approaches. The invisible boundary between their influences grows nearer with each passing day. In the next gentle step of our story, we will look more closely at the patterns surrounding this approach, the alignments that have drawn attention, the subtle coincidences that invite contemplation. Not to leap to conclusions, but to understand how easily the human mind begins to see intention in the dance of gravity and stone. Let the giant wait, let the traveller glide, and let us move slowly into the pattern of curves that has so quietly unsettled expectation. As Jupiter turns and the visitor glides steadily closer to that invisible shoreline of influence, another layer of quiet intrigue begins to surface, not in the dramatic sense of flashing lights or sudden revelations, but in the subtle geometry of alignment, in the way certain angles and timing seem almost too neat, too delicately arranged. It is here that the human mind becomes part of the story. We are pattern-seeking creatures. We look at clouds and see faces. We look at constellations and see hunters, bears, and heroes. When something rare appears in the sky, we do not merely measure it, we interpret it. We search for meaning in the curve of its motion, in the angle of its approach, in the coincidence of its timing. Our visitor arrived along a path that lies remarkably close to the ecliptic plane, the broad, flattened disk in which most of our planets orbit the Sun. This is not impossible. Space is full of trajectories, and given enough wanderers, some will align closely with any given plane. Yet the closeness of this alignment has drawn attention because it feels tidy. The visitor did not plunge in at a wild angle from some unexpected direction. It entered along a corridor already occupied by Earth, Mars, Jupiter, almost as if it were familiar with the layout. Probability tells us that unlikely things occur all the time when the stage is large enough. In a galaxy containing hundreds of billions of stars, even events with tiny odds become inevitable somewhere. Still, when we encounter such an event firsthand, when it unfolds within our own celestial neighbourhood, the statistics feel less abstract. The mind pauses, it lingers. There is also the matter of timing. The visitor reached its closest point to the Sun while hidden from our direct view. passing behind the glare that so often conceals delicate phenomena. It brushed past the orbital distances of inner planets without incident, neither colliding nor drifting far beyond their reach. Now it approaches Jupiter at a distance that grazes the boundary of that planet's hill sphere. Each individual detail is explainable, each can be described by the quiet mathematics of gravitational motion, and yet when placed together, they form a pattern that feels intentional, even if it is not. It is important here to breathe and remember that patterns do not imply purpose. If you toss enough stones into a still pond, some ripples will intersect in symmetrical shapes. The symmetry does not mean the pond intended it. It simply reflects the underlying rules governing waves. The visitor's rotation adds another piece to this gentle puzzle. Observations suggest that its spin axis points almost directly toward the Sun. Imagine a slowly turning stone in space, one hemisphere perpetually illuminated, the other remaining in comparative shadow. For most comets, rotation axes tilt in arbitrary directions, frozen relics of ancient collisions. To find one oriented so closely toward the central star feels unusual, but unusual does not mean impossible. The odds of any specific orientation are small, yet when considering all possible orientations across countless objects, some will naturally fall into striking alignment. The key question is not whether the alignment is rare in isolation, but whether it is rare given the vast number of potential configurations nature explores. We must also consider that these apparent anomalies may not be independent. The orientation of the spin axis could influence how jets of gas escape the surface. Those jets could, in turn, subtly modify the object's path. Trajectory and rotation are not separate stories. They are chapters of the same physics, woven together by conservation laws that never rest. When astronomers update orbital solutions, they refine them with extraordinary care. Each new observation narrows uncertainty. Sometimes two models differ slightly, by hours in predicted arrival, by a small fraction of velocity. These differences are not evidence of instability, they are reminders that measurement is a living process. As data accumulates, curves sharpen. Still, small discrepancies invite curiosity. If the visitor experiences non-gravitational acceleration from outgassing, that acceleration can shift arrival times by days over long distances. A jet of vapour escaping at just the right orientation can function like a faint thruster, adding or subtracting a whisper of speed. Over millions of kilometres, whispers add up. It is here that some observers begin to speculate more boldly. What if those tiny adjustments are not entirely random? What if they exhibit coherence beyond what chaotic sublimation would suggest? Yet before stepping into that speculation, it helps to remember how little we know about interstellar objects. We have only observed a handful. Our baseline for normal behaviour is fragile. We compare these visitors to comets formed in our own solar system, but they may have condensed around entirely different stars under different temperatures and chemical abundances. What appears anomalous to us might be typical elsewhere. There is humility in that realization. The universe is older than our categories. It does not consult our expectations before arranging its geometry. When we say something is unlikely, we mean unlikely given the limited data we possess. And yet the mind continues to circle back to the coincidences. Alignment with the ecliptic within a few degrees. Rotation axis aimed sunward within a narrow margin. Arrival near Jupiter's gravitational boundary with remarkable proximity. Chemical signatures that differ subtly from the comets we know. Each feature alone is a ripple. Together they create a pattern on the surface of the water. The danger is not in noticing the pattern, the danger is in assigning it intention too quickly. If you find yourself drifting here, imagining invisible hands arranging stones in space, it is perfectly natural. Stories are how we organise uncertainty, but science asks us to hold two ideas gently at once, that something may be rare, and that rarity alone does not imply design. There is also a quiet psychological element unfolding in parallel. We are living in an age when the search for extraterrestrial life feels closer than ever before. We send probes to icy moons. We scan exoplanet atmospheres for hints of biology. We listen for faint radio whispers between the stars. In such a cultural atmosphere, the arrival of an interstellar visitor cannot help but carry emotional weight. We want it to mean something. Even those who remain skeptical feel the pull of that desire. Not because they expect revelation, but because the possibility itself stirs ancient instincts. For as long as humans have watched the sky, we have wondered whether anyone else watches back, and so the alignments take on symbolic gravity in addition to physical gravity. It is worth remembering that selection effects shape what we observe. We detect interstellar objects precisely because they pass near the Sun, and by extension, near the plane where our telescopes are most sensitive. Objects on distant, highly inclined trajectories may slip by unnoticed. The ones we see are, by necessity, those that intersect our observational window. In that sense, alignment with the ecliptic may be less astonishing than it first appears. We are most likely to notice visitors that enter along familiar corridors. The same patience we apply to Jupiter's gravity must be applied to probability. Given enough time and enough wandering stones, some will trace elegant paths through our system, some will appear to thread needles in the vastness. The rarity of an event does not diminish its natural origin. It simply reflects the scale of cosmic possibility. Still, there is beauty in the pattern. The visitor's curve through space resembles a long breath drawn from darkness and exhaled back into it. It entered along a plane shared by our worlds, turned its illuminated face toward the Sun, and now glides toward the boundary of the largest planet's influence. Whether by chance or by deeper necessity, the geometry feels almost musical. In the next step of our journey, we will turn from these alignments of angle and timing to something more visible, more tangible, the strange behaviour of the material streaming from the visitor itself. We will look at the light it sheds and the direction in which that light and dust seem to flow. For now, rest with the idea that patterns can exist without intention, that coincidence can feel meaningful without being purposeful. The stone continues its glide. The darkness remains patient. And our minds, ever seeking shape in the void, learn slowly to balance wonder with restraint. As we leave the quiet geometry of alignments and probabilities, our attention drifts from invisible curves to something we can almost see with the mind's eye. A faint glow surrounding the visitor, a haze of dust and vapour that catches sunlight and scatters it back toward us across millions of kilometres of darkness. Comets, as you may remember from childhood textbooks or distant images in magazines, carry tails that stream away from the Sun. It is one of the simplest rules in astronomy. Solar radiation and the solar wind push particles outward, so the tail always points away from the source of light. Like ripples carried downstream, cometary dust and ionized gas trail behind, forming graceful arcs that curve gently through space. Our visitor, however, has displayed something more puzzling. From the earliest close observations, astronomers noticed a distinct feature extending toward the Sun rather than away from it. A sunward jet, what is sometimes called an anti-tail. Not a faint illusion glimpsed at the edge of an image, but a persistent structure, stretching outward in the direction that seems to contradict intuition. If you find yourself slightly unsettled by that image, that is natural. We are accustomed to rules, especially in the sky. The idea that a comet might appear to defy the simplest of them invites a small ripple of curiosity. Yet even here, patience is essential. There are known circumstances under which a comet can appear to grow a feature that points sunward. Perspective plays tricks across vast distances. When Earth passes through the orbital plane of a comet, dust that actually lies along the object's path can align in such a way that it seems to project forward. A geometric illusion, born not of reversed motion but of alignment between observer, sun, and drifting particles. Astronomy is full of such illusions, quiet reminders that position matters as much as physics. But the feature surrounding our visitor has shown persistence across changing viewing angles. It does not vanish when geometry shifts. It appears structured, column-like, almost disciplined in its direction. And so we look deeper. One possible explanation lies in rotation. Earlier we considered the way the object's spin axis appears to tilt toward the Sun. Imagine a slowly turning stone, one pole facing directly into sunlight. That pole would experience continuous heating. Volatile materials near its surface would sublimate steadily, releasing jets of gas and dust along that axis. If that axis points sunward, then the strongest jet might initially move toward the Sun, before radiation pressure gently sweeps it back. In that image, nothing defies physics. The material does not truly travel inward against gravity for long, it merely begins its journey along a sunward direction before being overtaken by the outward push of light. The jet becomes less a rebellion and more a choreography. Still, its persistence invites reflection. The structure appears steady, almost columnated, as if guided through a narrow channel. Cometary outgassing is often chaotic, multiple vents opening and closing as surfaces crack and warm. To see a feature maintain coherence over weeks suggests either a stable active region or a geometry that naturally channels material in a consistent direction. It is tempting here to leap ahead into dramatic speculation, to imagine engines rather than vapour, thrust rather than sublimation. But such leaps are rarely helpful in the absence of necessity. Nature is capable of complexity far beyond our initial intuition. Gas dynamics within a comet's coma, the glowing cloud surrounding its nucleus, can produce flow patterns that appear orderly from a distance. Interactions between jets can create shock fronts, boundaries where streams intersect and redirect one another. Under certain conditions, these interactions can shape the escaping material into structures that seem almost engineered. Yet, almost is doing gentle work here. The question becomes not whether the feature is strange, but whether it is so strange that no natural explanation can suffice. At present, the answer leans toward patience. We have seen only a handful of interstellar objects. Our expectations are calibrated on comets born around our own sun, under specific chemical histories. An object formed around a distant star billions of years ago may carry a different mixture of ices, a different porosity, a different response to heating. If its surface contains volatile compounds that sublimate at lower temperatures, activity could begin farther from the sun than we are accustomed to. If its internal structure channels gas through narrow fractures, jets might appear more focused than usual. Each unfamiliar trait may reflect not artificiality, but difference. And yet the human imagination does not rest easily. The idea of propulsion lingers at the edge of discussion. If the jet were not merely sublimating ice, but instead represented controlled exhaust, then small but continuous adjustments to velocity might follow. Such adjustments would accumulate slowly, altering arrival times or approach distances by subtle margins. Here again we must tread carefully. The measured non-gravitational accelerations can be accounted for by outgassing in most cases. Comets behave like faint rockets all the time, their icy cores responding to sunlight with reactive force. It is a known and measurable effect. Still, because we have so few interstellar visitors to compare against, every deviation feels amplified. Perhaps what truly fascinates us is not the jet itself, but the direction. Toward the sun, toward the centre. It feels symbolically charged, even if physically explainable. We are conditioned to see motion away from light, not toward it. If you find your thoughts drifting here, imagine the visitor not as a machine, not as a messenger, but as a weathered fragment of stone and ice responding instinctively to heat. Sunlight touches one face, molecules awaken and escape, dust is lifted and carried. The initial motion may be sunward, but gravity and radiation soon guide it outward again, like water poured upward, only to fall back under its own weight. There is elegance in that cycle. It is also worth remembering how faint these features are. The glow we interpret as a structured jet is thinner than any cloud on Earth, far more tenuous than the air in the highest mountains. What appears as a luminous spear in telescope images is, in reality, a sparse scattering of particles drifting in vacuum. Scale softens mystery, and yet the persistence of the feature continues to draw quiet attention. It has remained visible through changing phases of the object's journey, before and after its closest approach to the sun. Its structure does not fluctuate wildly. It endures. Perhaps that endurance tells us something about the stability of the active region on the nucleus. Perhaps it hints at a rotation period that maintains orientation over time. Or perhaps it simply reminds us that our understanding of cometary physics, while strong, is not complete. Science advances most often not through explosions of revelation, but through these subtle discomforts. A detail that does not fit perfectly. A feature that requires refinement of theory. The anti-tail, if we continue to call it that, may ultimately teach us more about how material behaves in the sparse sunlight of interstellar space. And so, we return to patience. The visitor continues its glide. Jupiter grows nearer. The The sunward jet remains visible, a faint stream against the blackness, neither proof nor refutation of anything beyond the complexity of nature. As the encounter approaches, attention will shift from this glowing haze to the broader question of what happens when the traveller crosses fully into Jupiter's gravitational domain. Will the curve remain smooth? Will fragments drift free? Will new objects appear among the distant moons? These are questions for the next quiet step. For now, rest with the image of light touching ancient ice, of vapour rising in delicate arcs, of a stone that has wandered between stars responding simply and inevitably to warmth. The darkness holds it gently, the sun illuminates it briefly, and somewhere ahead, the giant planet waits without expectation. The glow of the sunward jet lingers in our imagination as the visitor continues its quiet approach, and now the immense presence of Jupiter begins to fill more of the mental horizon, not as a threat, not as a gatekeeper standing guard, but as a vast gravitational basin into which paths curve and from which some never return. The encounter is no longer abstract. With each passing day, the distance between the traveller and Jupiter's hill sphere narrows. Invisible lines of influence overlap more deeply. What was once a gentle bend in distant calculations becomes an imminent crossing of domains. Jupiter is not alone in this region. Surrounding it is a wide family of moons, large and small, each following its own elongated path through the giant's gravitational sea. Some are massive worlds in their own right, layered with ice and ocean beneath frozen crusts. Others are no more than captured fragments, irregular stones drifting in retrograde orbits far from the planet's cloud tops. Among these smaller companions lie moons that were not born with Jupiter, but were gathered later, drawn inward and held under rare circumstances. Their existence proves something subtle but important. Capture, though difficult, is not impossible under the right conditions. Long ago, perhaps billions of years in the past, an object wandered too close to Jupiter at just the right speed and angle. Energy was lost, perhaps through tidal forces or collisions, and the object did not escape. It fragmented. Its pieces settled into eccentric, tilted orbits that remain to this day, quiet witnesses to a moment when gravity held rather than deflected. Our interstellar visitor approaches that same region of space, though under very different conditions. Its velocity is far higher than those ancient captives likely carried. Its path is swift and steep. By conventional physics, it will pass through without surrendering enough energy to remain. And yet, the mind cannot help but linger on the possibility of fragmentation. Comets are fragile. They are not monolithic stones, but conglomerates of ice, dust and void. As they warm and cool, stresses accumulate. Cracks form. Pieces shear away. We have seen comets split before, sometimes quietly, sometimes dramatically, leaving behind smaller companions that follow slightly altered trajectories. If such a separation were to occur near Jupiter, each fragment would carry its own unique path. Most would continue outward, still too fast to be captured. But a small change in velocity, just a fraction of the total speed, could shift an arc enough to alter future encounters. The physics here is precise, even if our tone remains gentle. To be bound to Jupiter, a fragment would need to lose a significant portion of its relative motion. Natural processes rarely provide such dramatic braking. Gas escaping from a comet's surface exerts only faint thrust. Tidal forces at the distances predicted for this encounter are modest. Under normal expectations, nothing will linger. Still, the scenario remains testable. Orbiting Jupiter right now is a human-made observer, a spacecraft that has been circling the giant planet for years. Its instruments study magnetic fields, radiation belts, the structure of deep storms. It was not launched for this interstellar visitor, and yet it happens to be present at the right time. From its vantage point, subtle changes in Jupiter's environment can be detected. Tiny gravitational perturbations can be measured. New objects in orbit, if any were to appear, would not remain hidden forever. Ground-based telescopes on Earth would also continue their watch, scanning for unfamiliar points of light among the known moons. This is what makes the coming weeks quietly fascinating. Not because we expect revelation, but because the encounter offers clarity. Predictions have been made, models refined. Soon, reality will unfold and curves will either match expectation or diverge slightly from it. The most likely outcome remains serene and unremarkable. The visitor will arc past Jupiter, its path gently sculpted by gravity, then continue outward toward the darker regions of the solar system. It will cross the orbit of Saturn months later, then drift beyond the distant ice giants, becoming ever fainter until even our largest telescopes can no longer follow it. But even a routine passage carries meaning. For the first time in history, humanity is able to watch an interstellar object interact with a giant planet in real time. Our ancestors would have seen nothing but fixed stars. We, by contrast, track motion measured in fractions of arc seconds. We compute velocities, refine ephemerides, compare observation with prediction. The sky has not changed, our ability to perceive it has. There is something deeply human about this collective act of watching. Scientists, amateur astronomers, students, and quiet enthusiasts all turn their instruments and their attention toward the same faint point of light. Not in panic, not in expectation of danger, simply in curiosity. The universe has sent a traveller through our neighbourhood, and we are awake to witness it. If you find yourself feeling a sense of quiet anticipation, allow it. Anticipation need not be sharp or anxious. It can be soft, like waiting for a tide to reach its peak before receding again. The visitor will enter Jupiter's gravitational sea, skim along its outer currents, and emerge altered, if only slightly. Whether that alteration is measurable in meaningful ways remains to be seen. But even the act of measuring, of comparing before and after, deepens our understanding of how gravity sculpts the cosmos. There is also a philosophical undercurrent here. We often imagine ourselves at the centre of events, yet this encounter reminds us of scale. The traveller does not know we are watching. Jupiter does not care that telescopes are trained upon it. The interaction unfolds according to laws that predate our species by billions of years. Our role is not to influence it, but to observe and learn. Perhaps that is enough. In the days surrounding closest approach, calculations will tighten, reports will circulate, graphs will update, and gradually the question of capture or fragmentation will resolve into data. Either nothing unusual will appear in Jupiter's orbit, or something subtle will demand explanation. If nothing appears, the simplicity itself will be beautiful. A visitor passed, a curve bent, a story completed without drama. If something unexpected emerges, then a new chapter in understanding will begin. For now, the great planet waits as it always has, its storms turning, its moons circling in patient loops. The interstellar stone glides inward, trailing its faint breath of vapour, carrying with it the accumulated history of another star. In our final step together, we will widen our gaze once more. Beyond jets and gravity, beyond capture and deflection, we will consider what it means, emotionally and philosophically, to witness such a wanderer, what it stirs in us, what silence it breaks, and what silence it leaves intact. The encounter approaches, but there is no need to hurry. The darkness between worlds is vast, and it moves at its own unhurried pace. As the visitor glides beyond the height of Jupiter's gravitational tide, whether altered subtly or not at all, something quieter begins to settle in. The calculations will resolve. The arc will either match expectation or bend by some measurable fraction. Instruments will record what they can, and the great planet will continue turning, indifferent to our curiosity. But long after the numbers stabilise, another question remains suspended in the dark, softer than physics and more persistent than probability. What does it mean that something from another star passed through our sky? Not what it proves, not what it threatens, simply what it means. For thousands of years, human beings have looked upward and imagined that the lights above were fixed, eternal, unreachable. We named the constellations and told stories about gods and heroes because motion was rare and unpredictable. A comet was an omen, a meteor, a sign. The sky was a canvas for meaning. Now we understand that the heavens are not fixed at all. They are dynamic, restless, shaped by gravity and time. And yet, even with that understanding, the arrival of an interstellar wanderer stirs something ancient within us. A fragment of stone and ice crosses between stars, enters our system, and leaves again. It is an event both ordinary and extraordinary. Ordinary because physics permits it. Extraordinary because we are here to see it. There is a temptation, when confronted with such a traveller, to ask whether it carries intention, whether it is merely debris or something more deliberate. We have touched gently on those speculations before, ideas of propulsion, of artificial origin, of hidden purpose. They arise naturally from the pattern-seeking mind, but perhaps the deeper reflection lies elsewhere. Even if the visitor is nothing more than ancient ice, even if every anomaly finds a mundane explanation, its journey still speaks to the vast interconnectedness of the galaxy. Material does not remain confined to one star system forever. Collisions, gravitational nudges, distant stellar encounters, these processes scatter fragments across interstellar space. Over billions of years, stars exchange debris like silent correspondence. In that sense, the visitor is a message, though not one written with intention. It is a sample of another stellar nursery, a piece of history formed around a sun that may no longer even shine. It carries chemical signatures shaped by environments we have never seen. Its atoms were forged in ancient stellar furnaces long before Earth existed, and for a brief moment it passed within the reach of our instruments. If you allow your thoughts to drift outward, imagine the galaxy as an ocean of darkness filled with currents of wandering stone. Most of those currents remain invisible to us. We detect only the rare fragment that crosses our narrow beam of awareness. The silence between detections does not mean emptiness, it means scale. We often speak of the universe as silent, as if we are alone in an endless void. Yet silence can be patience rather than absence. It can be the vastness of space stretching distances so immense that interaction is rare and fleeting. The visitor did not slow to greet us. It did not alter its course to announce itself. It followed a curve dictated by gravity, touched briefly by sunlight, and continued on. There is humility in that simplicity. Not every cosmic event centers on human narrative, and yet, our awareness transforms it. Because we can measure its velocity, trace its path, analyze its composition, the encounter becomes part of our collective memory. It becomes one more data point in the slow unfolding of understanding. The next interstellar visitor will be compared to this one. Patterns will emerge more clearly. What feels unusual now may someday feel routine. The future holds the promise of many such wanderers. New observatories will scan the sky more deeply, detecting faint objects long before they approach the inner planets. With time, we will build a catalogue. We will learn which features are typical and which truly stand apart. Until then, we remain in an age of first impressions. It is all right to feel wonder without needing certainty. Wonder does not require extraordinary conclusions. It requires only awareness. If you are listening to this in the quiet of night, perhaps the sky above you is dark and still. Somewhere out there, beyond what your eyes can perceive, the visitor continues its retreat into interstellar space. It grows fainter with each passing week, its reflected sunlight diminishing as distance increases. Eventually it will become indistinguishable from the countless other stones drifting between stars. But it will have left something behind, not a fragment in Jupiter's orbit, not a signal hidden in its wake, but a subtle expansion of perspective. We are part of a dynamic galaxy. Our solar system is not sealed. The boundary between here and out there is permeable. Stone and ice travel between suns. Gravity writes arcs that cross unimaginable distances, and occasionally those arcs intersect our own. There is comfort in that continuity. The darkness between stars is not hostile. It is spacious. It allows movement. It allows exchange. It allows stories like this one to unfold. As we close this journey together, let the questions soften rather than sharpen. Whether the encounter unfolded exactly as predicted or offered small surprises, the deeper truth remains unchanged. We witnessed a wanderer from beyond our system. We followed its path with care. We allowed ourselves to wonder without rushing to judgment. The giant planet turns on. The visitor recedes. The night sky remains vast and patient. And somewhere, perhaps far beyond our sight, other stones continue their long, silent crossings, waiting for some distant civilization to notice them and feel, as we have felt, that quiet stirring of curiosity beneath the stars.